All right, so I've been waiting to teach you guys this lesson, okay? I love the discriminant. So first off, we've discussed this, just to remind you. You have the quadratic formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this formula, this part right here is the discriminant. So the formula for the discriminant is b squared minus 4ac. The power of this is it's going to tell us about the nature of the roots. Okay, so let's take a look. Okay, number one, let's use the quadratic formula to solve. Okay, 3x squared minus 2x equals negative 1. 3x squared minus 2x plus 1 equals 0. Now, you can always do the discriminant first. I think it's going to be a good habit for you guys, especially considering how bright you are. Okay, I have b squared minus 4ac. So that's going to give me negative 2 squared minus 4 times a times c. The reason I would like you guys to do the discriminant on its own first, even if you do it mentally, is because then you're already going to know about the nature of the roots before you continue, okay? So I can already see here that this is negative, right? So I end up getting 4 minus 12, right? So that's negative 8. So this tells me that there's going to be 2 imaginary roots. Okay, so I'm solving this equation over the complex numbers. Which is a set of reals along with the set of imaginary numbers. All right, so let's continue with the quadratic formula. Make sure you always write x equals. That's a big no if you don't. So negative b is the opposite of b, right? So b is negative 2 here. You see a is 3, right? B is negative 2, and c is 1. Section that off. So we have 2 plus or minus the square root of negative 8. I have no idea why I just made that square root so long. Let me just erase some of that. Okay, over 2 times a. Well, that would be 6. From here, keep in mind, I can make this negative 8 the square root of negative 1 times the square root of 4 times the square root of 2. So that gives me 2 plus or minus then I have 2 rad 2i all over 6. Now I can take these and I can cancel out 2 in all of them. I call it the heart problem. Yes, that is my heart. So we have, divide them all by 2, so I get 1 plus or minus rad 2i over 3. So the solution set is 1/3 plus rad 2 over 3i and 1/3 minus rad 2 over 3i. All right, so continuing on, there's a theorem that you need to know. Okay, I'm going to write it up here. Okay, this is also written in your book on page 116. Okay, so a complex number, a plus bi is a root of a polynomial equation with real coefficients if and only if, which I told you guys earlier on, we can write as IFF. If and only if its complex conjugate A minus BI, okay, is also a root of the equation. So, we'll be doing examples of that. Now, as far as the nature of the roots, let's talk about the nature of the roots. So there are three things that can happen with the discriminant. Either the discriminant can be positive, the discriminant can be 0, or the discriminant can be negative. So in the first case, if the discriminant is greater than 0, the equation has two real roots. Okay, I want to say more about this. So b squared minus 4ac greater than 0. Okay, I want to add to this. If b squared minus 4ac is a perfect square, not equal to 0, obviously, because it's already greater than 0, then the two roots are real and rational. Okay? So then it goes without saying that if b squared minus 4ac is not a perfect square in this case, then the roots are real and irrational. Okay, so now for the second equation, in that case you have a double root, it's called. Some people will say it bounces there. And if the discriminant is negative, then the equation has two imaginary roots that are complex conjugates, which goes back to that theorem. Has two imaginary roots which are complex conjugates. So a double root, just to let you know, means like if you were to factor it, you would get two roots and the two roots would be equal. That's what's going on there. So I just wanted to mention that. So in the first unit, I had mentioned this to you. This way it would come in handy. So if the roots of the quadratic equation are rational, so when you go to use the quadratic formula, the answer comes out to be rational, then that means that the equation would be able to be solved by factoring. So in other words, this means that the discriminant is 0 or a perfect square. Okay, equals 0 or is a perfect square. So let's take a look at some examples. So the directions here are determine the number and nature of the roots. Okay, question A. 2x squared plus 13x plus 18 equals 0. So I'm going to do the discriminant. Okay, keep in mind A is 2, B is 13, C is 18. So I have 13 squared, which is 169, minus 4 times A times C. So that's minus 8 times 18, which is 64 plus 80, 144, 169 minus 144 is 25. So because it's 25, that means you're going to have 2 real rational roots. Therefore, there exist 2 real rational roots. So that means it's factorable. So if you were to factor this by grouping, we need 2 numbers that multiply to 36 and add to 13. So that's 9 and 4. Always try to make yourself do mental math if you care about my opinion. Because if you just use the calculator, down the line, you'll only be able to use the calculator. So, I know I could take out a calculator, but you know what? I'm going to try to do it mentally, because I think it's good for your brain anyway, guys. Keeps you sharp. So remember, we need this to match, 2x plus 9, so take out 2, so I have x plus 2 and 2x plus 9. So now you can see the roots are negative 2 and negative 9 halves, which are real rational numbers. So let's take a look at question B. I have 4x squared minus 20x plus 25 equals 0. Okay, A is 4, B is negative 20, C is 25. B squared minus 4AC. So that is 400. Keep in mind, this number is always going to be positive, by the way, so don't even think about it, okay? I know the way you guys are. You overthink, so don't overthink it. I know, easier said than done, right, kids? Okay, so that is 400 minus 400. That is 0, guys. So that means that there is a double root. It is factorable, but there is a double root. So there's one real double root. So when you go to factor this, by the way, and you can try that on your own time, you will get 2x minus 5 squared. So that means that 5 halves is the double root. Okay, so the third example, of course you know we're going to give you one of each type. This book is actually one of the best books that I've ever seen. I actually used this book when I student taught years ago in Herrick's. Yes, years ago, people. 27 years ago. Okay, yeah, I know. This book has been around a long time, right? What year was this book published? Oh, wow. Guys, no wonder I love this book. This is a book for dinosaurs. You guys can be a dinosaur just like me. So we get b squared minus 4ac. So I get 9 minus 4 times negative 1 times negative 5. So that's 9 minus 20, or negative 11. Well, because the discriminant gives us a negative answer, that means that the equation has two imaginary roots that are complex conjugates. Therefore, the equation has two imaginary roots that are complex conjugates. There you go, kids. Coolio, right? Now, there's a nice chart on page 117. Okay. I will draw it here. It just has to do with the roots. I think it's pretty much going to be common sense for you guys. So I want you to think about something first before I begin. So when you have an equation of the form ax squared plus bx plus c, when this value a is positive, this is extremely important. Okay, when a is positive, that means the parabola is going to open up. It's going to be a smiley face. But when a is negative, it's going to be a frowny face. Okay? So keep that in mind. So let's make this nice little chart here. So I have the discriminant. Then I'm going to take a look at A, so I know which way to draw my parabola. A greater than 0, A less than 0. And then we're going to talk about the number of x-intercepts, which is the roots. Okay, so remember we have three cases. We have b squared minus 4ac greater than 0, b squared minus 4ac equals 0, double root, right, less than 0. So I had mentioned this to you in class, but I told you don't worry, we'll revisit it. So here, okay, a is greater than 0, so we're going to have a smiley face, but there's two real rational roots. So it would look something like that. In the second example, it's just going to hit the x-axis once, because you really have a double root. And then in the last example, you're not going to hit the x-axis at all, so it's going to be floating above it. So similarly, when a is less than 0, it's going to, and b squared minus 4ac is greater than 0, you'll just have a frowny face, but you're still going to have two real roots. And then when we have 0, it's going to hit in one spot. And as you know, this is imaginary, so your frowny face will not hit the x-axis. So as we said, this is 2, this is 1, 0. Nice little chart to help organize your thoughts. Now, as far as graphing your parabola, okay, this is one of the things they're talking about in the book. Graphing it accurately. Okay, you did do this last year, but I'm just going to remind you that there is the axis of symmetry. Okay, just like the discriminant, this is also hidden in the quadratic formula, by the way. Here it is, guys. That is your axis of symmetry. So your axis of symmetry helps you to sketch your parabola because you know what it's going to be symmetric over. So that's one thing. So that is extremely helpful. And then you also want to remember that if you take this axis of symmetry and you substitute it in, because this is an x value, if you sub this in, okay, into your function, okay, you will get the y value it's paired with, right? And when you put those together, I'll call this f of negative b over 2a. This is known as your vertex. So you can always plot that point, which helps. Okay, you can always plot the y-intercept. The y-intercept x is 0. So these certainly help you. Okay. And another thing is, you know, you can find the y value, right, by subbing this in. So, you know, you can also substitute in some other values to the left and right of the axis of symmetry. Keep that in mind too. Okay, so let me sketch a graph. Okay, so I have y equals x squared minus 4x plus 3. Number 1, okay, you can do it in any order you want. I'm going to look at the axis of symmetry first. So I get 4 over 2, or 2. I sub that in. So f of 2 is 4 minus 8 plus 3, which is negative 1. So I would start off by going to 2, negative 1, because that's going to be my turning point. Then you know that you can get the discriminant, right? So let's get the discriminant. So we have b squared minus 4ac. So I get 16 minus 4 times a times c. So that's 4. So that means that we're going to have 2 real rational roots because 4 is a perfect square. So let's finish it up. Might as well finish up the quadratic formula. X equals negative b. So that's just going to be positive 4 plus or minus the square root of the discriminant over 2a. So this ends up being x equals 4 plus 2 over 2, and x equals 4 minus 2 over 2. So we get 3 here, and we get 1 here. So that means that, okay, those are your roots. So you want to go to x is 1, and you want to go to x is 3. Okay, now the y-intercept, okay, I'm going to make x equal to 0. So then I get y equals 3. So I'm going to go to 0, 3. And because of symmetry, because this is the axis of symmetry, guys, that means at 4, we can also go to 3. And I think that's a pretty parabola. Always label. Okay. So keep in mind that you should be able to do that. Something else that I want to mention. Let's do one, okay, where you don't have any x-intercepts, so you can see what that looks like. So we have y equals -1/2 x squared plus x minus 2. So I like to do -b over 2a first. -1 over 2 times -1/2. -1 over -1 is 1. Substitute that in. I get y is -1/2 plus 1 minus 2. So that's -3/2. So that means that I'm going to have a turning point at 1, -1.5. Now let's do the discriminant. So we have 1 minus 4 times -1/2 times c. So I get 1 minus, right? And then I can just say 4. So I end up getting -3, which is less than 0. So that means that it's not going to hit the x-axis. Now, because this is negative, it's going to be a frowny face. So keep that in mind. Now I'm going to get the y-intercept. So I'm going to replace x with 0, so I get y equals -2. So I go to 0, -2. And then keep in mind, because of symmetry, that means 2, -2 has a point as well. Okay, and that's a quick little sketch. Right, now there's one thing in the homework that I want to explain to you. Okay, I typed it up, but I want to make sure you understand it. So for numbers, all right, on page 120, you'll notice those directions are familiar. So I just typed up 33 to 39 odd. You're going to be doing those questions, so I'll take a look at this example that they do and just explain it to you. So you have x squared plus kx plus 36 equals 0. Now, let me tell you what the directions say first. Okay, find the values of k, could be one value, for which the given equation has one real double root. Okay, that's part A. Part B, find the root of the given equation for each value of k you found in part A. All right, so let's do this. So I want to find this value of k, okay, that has one real double root, and then I'm going to find the root for the given equation for the values of k that I found in part A. Okay? That's what it says for each value. So I start off, I have b squared minus 4ac. In this case, that would be k squared minus 4 times 1 times 36. So I get k squared minus 144. So k squared minus 144, right? We know that the equation has one real double root if the discriminant is 0, right? So if I take this discriminant now and I set it equal to 0. Sorry about that, kids. I had to take that call. Yes, I'm a real person. Okay, anyway. So I set x squared minus 144 equal to 0. So these values of k are the values of k for which the given equation will have a real double root, because I just made the discriminant 0, right? All right, now let's follow this through. So if k is 12, I'm going to sub back into the equation. I get x squared plus 12x plus 36 equals 0. And if I solve this equation, okay, look at this beauty, guys. This is a perfect square trinomial. It always will be when you have a double root. Perfect square trinomial. You might not recognize it so easily sometimes, okay, especially if this number is some kind of fraction or decimal. But at any rate, so when I solve this, I get x equals negative 6. And then when k equals negative 12, this yields x squared minus 12x plus 36. And in one of my videos I had discussed this would just be minus 6 then. I had a different example, but I don't know if you recall, but I did say that you have to look at this sign to determine this sign. That was a while back now, so I don't know if you guys remember that. But anyway, you get x is 6. That's a wrap. So those are the roots of the equation for the given values of k. Thank you.